What's up, guys? We're finally at our third episode of Math in New Era. Today we're going to be talking about quadratics and discriminants. These topics are familiar for middle and high schoolers. I'm going to go over the concepts and we're going to apply a combination of some of them in answering last episode's quiz question. Without further ado, let us begin. Quadratics refer to a function that involves the term x squared and forms a symmetrical curve we call a parabola when graphed. The most general form it takes is the y-intercept form, y equals to ax squared plus bx plus c, where a is not equal to 0. If the coefficient of x squared is positive, the curve opens upwards, and when it's negative, the curve opens downwards. A discriminant is a formula that helps us predict how many roots or solutions a quadratic function has. It is usually represented using an uppercase D and the formula b squared minus 4ac, taking the coefficients from the quadratic function. Firstly, we'll start off by discussing the main features of a quadratic function. Feature 1. The x and y intercepts. X-intercepts indicate coordinates of the function that touch the x-axis or the line y equals to 0. The y-coordinates of a function will always be 0 on its x-intercept. The y-intercepts indicate coordinates that touch the y-axis or the line x equals to 0. The coordinates of a function is always 0 on this vertical line. Feature 2. The axis of symmetry. Since the parabola is a symmetrical curve, we can draw a line in the middle of the graph to indicate where the halves of the curve are reflected. The equation is usually written as x equal to something, and if you have the function in the form ax squared plus bx plus c or the y-intercept form, you can use the coefficients to get the equation x equals to minus b over 2a. Similarly, if your parabola has two x-intercepts, you can add them up and divide them by 2 to get the middle point. Feature 3. The vertex. In a positive quadratic function, the vertex is the lowest point on the graph, while in a negative quadratic function, the vertex is the highest point on the graph. The vertex's x-coordinate is also the equation of the axis of symmetry because it passes through the vertex's coordinate. Next, we have different forms of writing quadratic functions that makes it easier for us to find the x and y intercepts as well as the vertex. Form 1. The x-intercept form. The first form we'll discuss about is the x-intercept form. It takes the form of y equals to a times x minus q times x minus p. Notice that when you make y equals to 0, you get x minus q times x minus p equal to 0. And it gives you x equal to p and q. Let's use the example y equals to 2 times x minus 4 times x plus 2. From here, we have q equals to 4 and p equals to negative 2. They become the x-intercepts because that's when y is equal to 0. To find its axis of symmetry, simply add 4 and negative 2 together and divide the sum by 2. It gives you the middle point at x equals to 1, which also happens to be the vertex. If you've found the axis of symmetry, you've also found the vertex's x-coordinate. To find the vertex's y-coordinate, you can use x equals to 1, substitute it back to the equation, and you have the y-coordinate. In this case, we get the y-coordinate as y equals to negative 18. So the vertex is located at 1, negative 18. Form 2. The y-intercept form. This is the form that we've been using since the start of this video. The form y equals to ax squared plus bx plus c is really helpful when trying to find the y-intercept. That's why it's named that way. When you make x equals to 0, all that is left is y equals to c. Let's use an example of y equals to 2x squared plus 3x plus 4. When you substitute x equals to 0, you get directly y equals to 4. Using this form, we have its axis of symmetry as x equals to minus b over 2a, where a is equal to 2 and b is equal to 3. So, substituting those values, we get x equals to negative 3 over 4. Similar to before, we can substitute the x value from the axis of symmetry to the equation, from which we get 23 over 8. The vertex is found at negative 3 over 4, 23 over 8. Form 3, the vertex form. This last form helps us get the vertex's coordinates real quick. It takes the form of y equals to a times x minus h square plus k, and the vertex is located at hk. If this form is not directly given in a question, you can change the y-intercept form into this form. If we have the same function as earlier, y equals to 2x squared plus 3x plus 4, and we would like to change it into the vertex form, we can do something called completing the square. Firstly, we take out the coefficient of x squared and divide the first and second terms with it while leaving the constant alone. We get y equals to 2 times x squared plus 3 over 2 plus 4. Now divide 3 over 2 by 2 and remove x squared's power to outside the parentheses. Now we have y equals to 2 times x plus 3 over 4 square plus 4. But we're not done yet. Notice that if you expand 2 times x plus 3 over 4 square, you have 2x squared plus 3x plus 9 over 8, while all that we need is only 2x squared plus 3x. Subtract the excess 9 over 8 to cancel it out. Don't forget the plus 4. Subtract 9 over 8 from 4 and you get your new constant 23 over 8, which is the same result obtained as our previous discussion on the y-intercept form. Next, we'll be talking about discriminants and how the number of roots of a quadratic function depends on the value of the discriminant. Discriminant case 1, d is bigger than 0. To evaluate a discriminant, the function's form should be in the y-intercept form, so you can use the values of the coefficients as a, b, and c in the discriminant formula. Recall that the formula is d equals to b squared minus 4ac. If the value of d exceeds 0, it means that the function has two different real roots or solutions, and the 2 points on the function will intersect with the x-axis. Discriminant case 2, d is less than 0. Recall our example earlier when y equals to 2x squared plus 3x plus 4. When we apply the values into the discriminant formula, we have 3 squared minus 4 times 2 times 4 equals to negative 23. Which is less than 0. This means that the function has no real roots and doesn't have an x-intercept. If you remember the quadratic formula, x equals to minus b plus minus square root of b squared minus 4ac over 2a, you'll notice that the part under the square root is the discriminant formula. We also know that roots cannot be negative, thus if it is, then the x value when y equals to 0 doesn't exist, leaving the function with no x-intercept. Discriminant case 3, d is equal to 0. If your discriminant's value is equal to 0, your function has exactly one real solution. This means that only one point on its graph will touch the x-axis, and it has to be the vertex, because it's the only point that has its own y value, while the other y values have 2 points due to symmetry. Discriminant case 4, d is bigger than or equal to 0. The last case is when your discriminant's value is bigger than or equal to 0. This means that the function has two identical roots, and similar to when the discriminant is equal to 0, it only has one of its points touching the x-axis. An example is when you have y equals to 2 times x minus 2 square. The function is said to have two real roots because you can expand the example to 2 times x minus 2 times x minus 2. But still, only one point of the graph lies on the x-axis. So those are the basics of quadratics, discriminants, and how to use them to predict how many roots should occur in the graph. Did you know that quadratics can be very useful in real life? If you run a business, you can model the increase or decrease of your revenue using the concept of quadratics. The axis of symmetry can help you predict the peak of your success or the lowest point in your career. This is why understanding the concept of quadratics is beneficial to us students. To apply the skills we've learned in this video, let us use it to answer last episode's quiz question. If you haven't seen it, here it is. Pause the video to try it out and resume when you're ready with the answer. Here's how we'll solve it. So, we got fx equals to a squared x squared minus b minus 2x plus 3c. And the information that it meets the x-axis at 3, 0, and the y-axis at 0, negative 15. We also have gx equals to 2bx squared minus 3ax plus 1, and it exactly has one solution. We're trying to find the values of a, b, and c when a is bigger than 0. Firstly, we'll work with fx. We can input these 2 points into the function. So firstly, we'll work with the x-axis, fx equals to 0. Substitute 3 into x, so a squared, 3 squared is 9, minus b minus 2 times 3 plus 3c. Evaluating this side, we have 9a squared minus 3b plus 6 plus 3c equals to 0. We can move 6 to the other side. 9a squared minus 3b plus 3c equals to negative 6. We can place this as our first equation, and then we'll work with the y-axis. We have x is equal to 0 and fx is negative 15. So negative 15 equals to, notice that if you put 0 into x, the terms cancel out because it's multiplied by 0. So then 0 plus 3c is equal to negative 15. Therefore, 3c is equal to negative 15 and c is negative 5. Next, we'll work with gx. We know that if a function has exactly one solution, that means the discriminant is equal to 0. So we have the formula b is equal to b squared minus 4ac. In this case, b would be negative 3a squared minus 4. A would be 2b, and c is 1. So we have 9a squared minus 8b equals to 0. We can move 8b to the other side, so we have 9a squared equals to 8b, and this is our second equation. We can substitute the value of 9a squared into the first equation. So putting the second equation into the first equation, we have 8b minus 3b plus 3c equals to negative 6. We know that 3c is negative 15, so evaluating the front, 5b minus 15 equals to negative 6. We get 5b equals to 9, negative 6 plus 15, and we get b is equal to 9 over 5. We can substitute the value of b back to the second equation, so 9a squared equals to 8 times b is 9 over 5. Divide both sides by 9. So 9 over 5 times 1 over 9. You can cancel 1 over 9 and 9 over 5. You get 1 over 5 left, so a squared equals to 8 over 5. We can take the square root to get only a, and since a is bigger than 0, we only take the positive root. So a equals to square root 8 over square root 5. Simplifying square root 8, we get 2 square root 2 over square root 5. Rationalize the denominator. We have 2 square root 2 times square root 5 over 5, which is 2 square root 10 over 5. So we have A equals to 2 square root 10 over 5, B is equal to 9 over 5, and C is equal to negative 5, for which we get these values. So those were the basics of quadratics and discriminants. I hope you've had a better understanding of the concept and come to realize that it's applicable in our daily life. Next episode, we're going to be talking about the transformation of functions, which still involves quadratics. As usual, have another quiz question to get us ready. The answer and the method will be revealed next episode. Thanks for watching. Till we meet again.